So this is Hardy-Weinberg solving example 1. So we have a population of rabbits and the coat color of the rabbits is determined by a single gene with two alleles. So there's big B, which is dominant and is for the black coat phenotype. And we have little b, which is recessive and is for the white coat phenotype. You survey the population and find that 64% of rabbits have black coats, which is dominant. And we assume that the population is in Hardy-Weinberg equilibrium. And so we need to find the frequency of the big B allele, the little b allele, and the frequency of the heterozygous individuals in the population. So in order to solve this, we have two equations, which is P plus Q equals 1 and P squared plus 2PQ plus Q squared equals 1. So P right here is the frequency of the dominant allele, which is big B. Q is the frequency of the recessive allele, which is little b. P squared, which is here, is the proportion of the population that is homozygous for the dominant allele, which is big B, big B. 2PQ is the proportion of the population that is heterozygous, which is big B, little b. And Q squared is the proportion of the population that is homozygous for the recessive allele, which is little b, little b. So we know already that 64% of rabbits have black coats, which is dominant. So we want to find the percent of rabbits that have white coats, which is recessive. We want to find recessive because this black coats, which is dominant, can be either big B, or big B, little b. But if it's recessive and has the white coat, we know it has to be little b, little b. And so that's why we solve for recessive. So 100% minus 64, which is the amount of rabbits with white coats, equals the percent of the population with white coats, which is 36. Oh my God. So that is the percent of the population with white coats. So, and this is just 0.36. So this would equal Q squared because this is the proportion of the population that is homozygous for the recessive allele, which is little b, because this is the percent of the population with the white coats, which is recessive. So to find Q, we just take the square root of both sides, and we get Q equals 0.6. And so Q equals the frequency of the recessive allele, which is this. So we already know for the second question that it would be 0.6. So now we need to find the frequency of the big B allele, and we use this equation, which is that P plus Q equals 1. And we already have Q right here, so we do P plus 0.6, which is Q equals 1. And we subtract 0.6 from both sides, and we get P equals 0.4. And this is the frequency of the big B allele, which is the dominant allele. So now we need to find the frequency of heterozygous individuals in the population. And we know that the frequency of heterozygous individuals in the population is 2pq because 2pq is the proportion of the population that is heterozygous. So we already know p, which is 0.4, and we know q, which is 0.6. So we just do 2 times p, which is 0.4, times q, which is 0.6, and we get 0.48. So the third question is equal to 0.48.